working on is basically finished up. The work I had done to like prepare the JIT is complete. I'd maybe spend some time thinking about how we might approach introducing a REPL. The constraints are, we have to like replace code at like an object file level, but we can do some, interesting things like generate a module that contains just something simple and then load that into the JIT and invoke a function that it defines or expose. We can redefine functions, things like that.
Does the JIT support have like what Windows does, where they put like two nops at the beginning of functions that you in DLLs that you want to be able to replace with a side-by-side DLL later, so that like you have an insertion point to jump to the other version?
We can take it a step further, yes, and CodeGen actually support that kind of functionality where we can just change the actual implementation of the function. In our case, though, we can simply just discard the old version of the object and reload the symbol. So the JIT supports sort of like lazily resolved symbols or re-exported symbols or indirect symbols. So that lets us have, a bunch of compiled code reference like the indirect stub and then replace the actual function, like where that code lives each time the function changes. So that's easier for us because we don't actually have to change our code gen strategy at all. We just have to figure out, what allows us to get sort of the REPL type environment, right? So it's kind of stateful. You can do things like redefine, functions, values, all that, be able to reference things you've already, expressed in the REPL. So if we were going to re-implement, the Erlang shell, so to speak, on top of, the LVM JIT infrastructure, how would we go about it? And I think from my perspective, that mostly boils down to how do we get the statefulness part of it to work properly. There's probably some ways that we can kind of hack around it to give the illusion of that, even though it's not really super stateful. I haven't actually looked to see exactly how Erlang handles it internally, but something to keep in mind anyway.
I thought the history of values part, at least in IEX, I don't know if it's the same in Erlang, it's literally just process dictionary.
Right, that would make sense because you can reference things by like an index. So we could take that kind of approach.
And I think the process dictionary also has the benefit of that it's why remoting works and you don't lose your history. Like you can lose your remote shell and reconnect and you still are in the same shell unless you crash it because it's the same process dictionary, I think.
Right, it's always the local shell's process dictionary. So if you have a remote shell, you don't lose you lose your remote history, right? Because in that case, the shell history is in the remote node, or is it?
Yeah, I can't remember which side it's on, but I know like it remembered.
I think actually it is always local, and the only thing that changes when you're logged into a remote node is the IO redirection. Because that would make sense. You wouldn't want the shell process to just be accumulating like history indefinitely, or like hold on to some absurdly huge object accidentally, that kind of thing. So if it's always stored in the in the local shells process dictionary, then you can toss your shell away and automatically clean up all that stuff. Anyway, yeah, I think ideally what we could do is sort of take the code for the Erlang shell and kind of modify it to use a slightly different set of built-ins so that it works with the LVM JIT. The only thing that really needs to change, of course, is how the code is evaluated, how compilation works. But I think a lot of the shell implementation doesn't need to really change. There's not a whole lot of practical difference from our perspective.
I know the pry one for IEX is just converting the Elixir to Erlang and then using Erlang compile. I do not know if based IEX works the same way or if the Erlang shell works the same way, because there's that weird thing where like the Erlang shell used to not be able to, you couldn't define functions, but like Elixir is fine with that. And I don't know why that is different. I never looked into it.
But I mean, you can't define functions in line in the Elixir shell, as far as I'm aware. That change at some point.
It's
you can define
like
modules. You can't define modules in Erlang shell because obviously there's no way to terminate it.
Yeah, in IX, I think you can only define anonymous functions.
No, Paul's right, because you can do with in the shell, which means it does macro evaluation, which is why you can define modules, because it's just a macro.
I mean, in theory, you could define modules in the Erlang shell as well. They would just need an explicit terminator for the module boundary. That's the main problem right now, is that you start a module definition, and how do you end it? So the approach I was thinking is, like, if we wanted to actually support that, we could just recognize that if, like, you do -end, the preprocessor directive for that, and the last open or unclosed expression is a module, then it just terminates that module. That's an optional thing. It's not something we need to support, but it might be useful. It always kind of annoyed me that, in the Erlang shell, you can't do that.
I mean,
it's sort of difficult to, like,
also, if everyone ends up just
models.
switching into Elixir once we get Elixir running, it won't. We don't want to be worse than Erl or IEX if we can help it. But like being better isn't that big of a deal.
Yeah, no, I don't think it's necessary for us to, like, be strictly better. But I do think if we can, fix some issues fairly easily without, large implications, like changing behavior that people sort of rely on, then it's probably worth it for us to evaluate those things. If it's as simple as, like, adding a couple lines of code, that's an easy way to, improve things that we're working on. If it's like a couple hours of work or more, then maybe it's a different calculus, right? Because we have enough to work on that we don't need to be wasting time on too much stuff like that. But, I think that's one of the more compelling arguments for alternative implementations, is that you have the opportunity to address some of those more annoying issues. But in any case, the important thing for my perspective is just that we come up with a strategy for how we'll support the shell on top of the JIT, because I do think that that's a pretty important part of just the general workflow, and being able to experiment in the shell with our compiler, I think, will really help both our own just experimentation as well as people wanting to play around with it. In any case, it's sort of a secondary feature, but the main thing that I wanted to support was just, like, JITting things that we're testing, so we can just generate some code, evaluate, the actual function, test against the result, and then dispose that compiled module, which will make our test suite a lot faster rather than having to test against, generating an artifact, doing all that shit, and then, trying to parse strings and stuff. It's a lot easier for us to actually test against the real data. I still think we need a set of tests that do run the actual compiler. It's just a lot easier for us to write stuff if we can run it via the interpreter. For one thing, supporting file check becomes much, much easier because we can just pipe code into the interpreter, have it spit out the result without ever having to compile stuff and write files to disk and stuff like that. That's basically how, LLVM does most of its testing, as does MLIR. They run everything through the interpreter, which is, LLC or LLI for the actual shell thing and LLVM, and then MLIR CPU runner, I think, is the version for MLIR. But anyways, so that JIT work is done. I updated LLVM, which included a number of breaking changes. Those have been addressed. In fact, a pretty significant refactoring of like a lot of dead code and stuff in both the LLVM and MLIR crates was done. There's now a boatload more like C implementation or C API provided by MLIR. So the MLIR crate now contains all of the Rust implementation of that. And the bulk of the code that was previously written in C++ and we were calling through our own home-rolled FFI to do a lot of things is now just using the MLIR crate and the C API that they provide. The exception to that is there are a few functions here or there that is just either necessary because it wasn't actually implemented yet in MLIR or LLVM, or it's just more convenient to define a helper function in C++ and just expose it as C. But all of that reduces a significant amount of code in another language that we have to manage and just extra complexity. So it's a little bit easier to navigate some of that code now. And what was the other thing I was thinking of? I'm ready whenever Hans is done with like updating EIR to use the latest allocator stuff in nightly so that we can update Lumen.
Yeah, I'm sorry about that because I have a whole lot of changes locally and I was trying to finish that up as well and get them pushed up at the same time. But I think I'm going to just have to push up just the allocator changes so you can move forward on that, and then I'll try to get everything else done after that.
Sure, yeah, no worries. I mean, if it's going to be a couple days or whatever, don't worry about it. I can wait. But if you think it'll be a while, then
I'll at least get it done this weekend. Then I'll have time to work on it.
All right. Well, I'll just wait, I guess, until you get things wrapped up. It's not a huge rush.
Awesome. Yeah.
And then the last thing on my plate that I need to try and revisit this week is garbage collection. So that's all for me.
Nothing for me. I don't get time for Lumen until this Friday.
Nothing in particular from me. I've run the scripts and noted that there wasn't much to write about, so I haven't written about them.
Yeah, I meant to push the LVM. Well, I pushed the LVM changes. I think I just haven't tagged any release.
Yeah, if you merge something that you think it's worth bring in so we get a decent weekly summary or bi-weekly or whatever we're at, just ping me and I'll make it happen.
For sure. And I think, if you open the PR for like what's changed, I can still go in there and write notes on, what progress was made, even if there weren't commits.
Oh yeah.
That way, at least, if people are paying attention, they'll get something, some sort of communication.
Yeah.
Luke, do you have a sense of like what you are planning to work on Friday when you get a chance to?
I will likely, since after you push the big changes, I never went through and reevaluated OTP to see like, did the errors change or are they still there? I will. That's the first thing I'll look at. And then if by some magic like application like just works, then I will try to get us to stop booting init start and like boot real init and like start to have application trees.
Yeah, they'll probably take a little bit of coordination with the front end to make sure that the way things are set up, that we know like what the root application is. So we know where the entry point is. Like for testing purposes, you could just hard code that. But
I was hoping so.
When you generate an entry
for the current tests, they will keep working. But for the ones that like the application is on, we should be generating application start from the Erlang code in OTP, or at least our forked version of it. And so like the code won't know the difference. Like the code that the compiler generates shouldn't know the difference. It's just I won't literally write application start in Erlang file anymore.
We still need to have the set of applications to actually load.
I thought init start did all the loading and application master does. So like the Erlang code we would pass it would do that. It's not something the compiler has to know about.
We can't just use Erlang's init start directly. Like
no, I get that. Like it's going to fork because it can't touch the file system like init start actually does. But as soon as we change it, like does the front end really need to know that, or doesn't it?
Well, the front end is what's going to gather like which applications need to be compiled, and then from that, which files need to be actually compiled. And one of the artifacts that we want to produce probably is just like a static global or something.
Oh yeah, that's true. The
set of applications and the order in which to start them.
That is true.
File, basically.
The runtime, you made it so that like the clap stuff can do the equivalent of parsing like a script.boot, but we would do that all as just a hard-coded global, so we don't have to have clap because it's a huge dependency. Right. So that part. I'm not going to worry about it until I show that OTP compiles cleanly, because like I haven't looked at it.
And that's definitely like after I get the garbage collection stuff done, that's the next thing that I'm planning on tackling, is updating the front end to do that stuff. Well, it's a bit of front end, bit of the back end, but mostly just want to change the compiler so that it is thinking about Erlang code in terms of applications rather than just as like arbitrary set of source files.
Mm-hmm.
You go down a level and that's ultimately what it is. But one of the things I stripped out of kind of the design that Rust-C has is the concept of like what crate is being compiled and then dependencies between crates, because at the stage that we've been at, we didn't have that information available. But as soon as we do have that, it changes like how we compile modules. Instead of going module by module, we compile like applications together as a translation unit. That lets us do, intra-application procedural optimizations without, having to limit the scope down to a particular module. Gives us a better dead code elimination, things like that. we'll still need to do LTO eventually in order to do dead code elimination for the stuff that's between applications. But
yeah, because if we want to LTO like gen server implementations into the actual with the behavior, we need LTO since they'll be separate applications.
Right, and probably one of the things that we'll need to figure out is how we can maybe compile things like gen servers so that the implementations are inlined, rather than it being like some code that doesn't know anything about what's actually being executed.
Yeah,
we've sort of merged together the gen server behavior into its implementations. That'll let us do much more aggressive dead code elimination.
I think we'll have to try out to see how it turns out for code size. Like for embedded, it might not matter, and like for native, like obviously the speed is better. But for WASM, I'm curious about the amount of inlining that will be good, just from what the blog about the JIT for OTP was, were like having too much inlining, like, and that they actually ended up outlining like their reduction check, but not as a function, but as like
inlining is not the critical optimization here. Dead code elimination is, and you can really only do that if you can statically resolve what's actually being used. And in many cases, I think, well, it's probably not fair to say in many cases, but I suspect that, for a number of modules, there's quite a bit of effectively dead code that's not actually used because, they're simple implementations. Maybe they don't use a particular callback at all, things like that let you strip out a lot of that code. But, it might be the case that, that ends up being more of a performance optimization where flattening out, like monomorphizing behaviors like that, ends up being faster, but increases the code size. I don't know. I think you're right that we need to evaluate that for sure. But I think one of the issues that it resolves is sort of like these blind function calls where we just have to wait until runtime to see if somebody references a symbol that doesn't exist.
Yeah, especially for the gen server stuff, because we know they're not that blind because they're always calling a specific function with a specific arity.
Right. Yeah, so the function calls there are expensive and they also lose their tail call like support, basically.
So if we have an apply, it won't count as a tail call anymore?
No, it can't because it doesn't know like whether the signature matches.
I mean, that's probably a problem because apply in normal Erlang counts as a tail call.
Yeah, I mean, there are ways in which we sort of hack around that. The early implementation I had of in fact, the dynamic apply stuff does tail call, but the issue is whether the code can be generated with the must tail attribute. And that can only happen if the signatures line up, which in practice happens when we statically resolve things. But if we're doing completely blind applies, then we lose that capability, which is why I do everything I can to avoid using apply. So generating code without apply is preferred in virtually all circumstances. Otherwise, it's just, there's nothing you can do if you're, because right now the like route that you have to take to do a dynamic apply, at least via the implementation and Lumen OTP, or is like 3 or 4 calls deep.
Yeah, because we have to handle the case in case you messed up.
Right, but we don't have to do that if we statically resolve the calls. So that extra like set of call frames, we can't tail call with that. Like there's no way to flatten that. With LTO, it might be able to do inlining and be able to deal with it that way. But I mean, we still have like code in there that I don't think it will be able to tail call optimize. So making every effort we can to avoid dynamic apply is essential, I think. We've been kind of glossing over that fact because it hasn't been critical up until now. We just kind of use it liberally, but we're going to need to shift it back the other direction as soon as we're able. Right now, I think we largely use apply more than anything else. Where when the compiler was initially written, it was never using dynamic apply except for truly like, dynamic calls. But because we wanted to handle the behavior of calling a function with like the wrong number of arguments and stuff, we ended up routing everything through apply.
Is there a way to write apply in C so that we can use the attributes to get the equivalent of must tail? Like, because you can use attributes for like the GCC and claim extensions to give the equivalent of must tail.
I mean, I can generate the code with those, but must tail will fail if it doesn't meet the necessary conditions to be tail call optimized.
Okay.
So our solutions are, if we can't generate code that we can successfully apply must tail to, then we either need to write assembly to make it work, reuse the current call frame, or make sure that the code that we're generating can be tail call optimized. And I think with static analysis, the idea here is that we can make assertions about the code that let us strip out the need for using apply for those calls. We know things like the number of arguments, that the symbol exists, all that stuff in advance. The only thing that remains is calls where, we don't know something. And I think in the general case, back when we first started the evaluation of all this, like the vast majority of calls do not need to be blind. They can be statically resolved. It was just more of a shortcut, I think, in terms of implementation to just route everything through apply. Recently, it was not that way for a while, but it has been as of late. But, with some of the refactoring being finished up, we can transition back the other way. But the big if, or not if, just the big question is, how do we deal with things like GenServer, where, they're very common and the implementation of those things necessarily requires dynamic applies. And constant propagation might, in some cases, address that, but I'm not sure. We'll need to do some testing to get a sense of like statistically how many calls like that remain blind, and then we'll come up with a solution that lets us, actually change those into statically resolvable calls. If that makes sense.
Yeah.
Well, I guess if that's it for now, Hans just pinged me like this weekend or whatever, when you get that stuff pushed, if it's not until like next week, no worries. Just, if you happen to finish it up, give me a shout.
Will do.
Other than that, I guess we'll catch up again next week. Have a good one.
Yeah.
Oh, Luke, if you're working on things on Friday and you hit anything, definitely just ping me and let me know.
Okay.
All right.
Okay, guys.
Take care.
Bye.
Bye bye.